Introduction. The objectives are 1. To be able to verify the Bernoulli's principle through simple experiments, and 2. To be able to observe the movement of air in accordance to the air pressures in space. The principle is, a fluid is a subset of the states of matter consisting of liquids, gases, and plasmas. They have common characteristics that are not present in solids. A fluid does not have definite shape, but it takes the shape of its container. They also pour when under the influence of a force such as gravity. The science that deals with fluids in motion is called fluid dynamics. There are basic principles in fluid dynamics, and among them is the Bernoulli's principle. It was in 1738 when Daniel Bernoulli, a Swiss mathematician, published an article about his discovery that moving fluids have lower pressure than the fluids that are at rest. And now, this is now the so-called Bernoulli's principle. This principle states that the rise in pressure results in decrease in speed, and conversely, increase in speed results in fall of pressure. The Bernoulli's principle can also be expressed mathematically as P plus 1 of PV squared plus PGH equals constant, where P is the pressure, P is the density, V is the velocity, H is elevation, and G is the gravitational acceleration. Since theoretically, air moves from area with high air pressure to an area of a lower air pressure, this principle, together with Newton's law of motion, has an important role in how objectives fly. In fact, it is applied in designing flying vehicles such as airplanes.
Experiment 1. Blowing a strip of paper. Materials needed. 1 piece of paper. Procedures. Number 1. Cut a long strip of paper about 5 centimeters by 20 centimeters. Number 2. Place the strip of paper below your lip. 3. Blow over the paper. 4. Observe what happens to the strip of paper. In the first experiment, the blown air travels fast on the top of the paper, which means the air pressure above the paper is low. In addition, the air below the paper is moving slower, which means the air pressure below is higher than the air on the top of the paper. The slower moving air has higher air pressure, pushing the paper up to the lower air pressure region.
Experiment 2. Blowing between 2 sheets of paper.
Materials needed are 2 pieces of paper. Procedures. 1. Prepare 2 sheets of paper. 2. Hold up 2 papers vertically with small space between them. 3. Try to blow between the 2 sheets of paper. 4. Observe what happens to the sheets of paper. In the second experiment, the air between the papers has high velocity and low air pressure, while the space beside the papers have low velocity and high air pressure. Because of this, the high air pressure moved to the region with low air pressure, pushing the 2 papers towards each other.
Experiment number 3, magical plastic cups. Materials needed, 2 plastic cups. Procedures. Number 1, place the 2 plastic cups parallel to each other and 3/4 inch apart on a flat surface. Number 2, blow between the 2 cups about 1 and 1/4 inches above the surface of the table. Be sure to blow in front of the cups and not between them. Number 3, observe what happens. In the third experiment, the air blown to the cups has higher velocity than the air on the other side of the cans. And because high velocity creates low air pressure, the air from the higher pressure region, which is the other side of the cups, tried to move toward the lower air pressure region, causing the 2 cans to move toward each other.
Experiment 4. Levitate a sphere.
Now, for the experiment number 4, levitate a sphere. Materials needed are 1 ping pong ball and 1 medium-sized funnel. Here are the procedures. Number 1, place the ping pong ball in the funnel. Number 2, tilt your head back and point the wider end of the funnel upwards. Number 3, blow air forcefully through the narrow end of the funnel in an attempt to lift the ping pong ball out of the funnel. Number 4, observe what happens. Number 5, now, with the ball in the funnel as before, hold the funnel in front of you and blow forcefully across the top of the wider end of the funnel.
In the fourth experiment, when the air was blown from the narrow end, the ball stayed in the funnel. If we are to analyze, the air blown through the narrow end of the funnel has high velocity than the air over the ball. And according to the Bernoulli's principle, an increase in velocity results in decrease in pressure. Because of this, the high air pressure above pushed the ball towards the funnel. When the air is blown over the top of the funnel, the high velocity is now on the top of the ball, which means it has lower air pressure than the air below the ball. Because of this, the ball levitated because the high air pressure below the ball moved towards the area with low air pressure pushing the ball upwards.
For the experiment 5, floating ball, the materials needed is 1 hair blower and 1 ping pong ball. The procedures are: first, turn on the hair blower and face its hole upwards. Second, place the ball on the stream of air and from the hair blower. Third, observe what happens. Fourth, try to tilt the hair blower. And lastly, observe what happens.
In the fifth experiment, the air from the blower has high velocity. As the air goes to the ball, the air is lower because the ball served as a obstacle in the airstream. The airflow becomes fast again as it passes through the ball. For short, the changing of air pressure is from low air pressure becoming high air pressure, shifting to low air pressure. The ball stayed in the air because the air from the blower pushed the ball upward, while the high air pressure surrounding it goes to the region where there is low air pressure, pushing the ball in its position as it starts to move away from the airstream. As the blower gets tilted, the ball still remains in position. Indeed, the gravitational force is there, but this just means that the force exerted by the air pressure is greater than the gravitational force.
In conclusion, Bernoulli's principle has been applied through simple experiments. Because of this, the said principle has been verified. Therefore, low air speed creates high air pressure, while high air speed creates low air pressure. In addition, air moves from area with high air pressure to an area with low air pressure.